Now, let's study valency. What is valency? It's the combining capacity of the element to form compound. The atoms, they become radicals, and radicals, they get attracted and they form compound. So, valency is the combining capacity of the element and the radical. They don't form compound just randomly. It is due to the valency that they get attracted and they form compounds. So what is the definition of valency? The valency of an element or of a radical can be defined as the number of hydrogen atom that will combine with or displace one atom of that element or radical. This is the definition. So it is the hydrogen. The hydrogen has got valency 1. So it will combine with other elements. So how many hydrogen are required by that element that forms the valency? Or how many it displaces that forms the valency? Hydrogen requires 1 chlorine to form compound. Therefore valency of chlorine is 1. It requires 2 oxygen to form H2O, therefore valency of oxygen is 2. 3 hydrogen is required to combine with 1 nitrogen, therefore valency of nitrogen is 3, NH3. CH4, 4 hydrogens are required to form methane, to combine with 1 carbon, therefore the valency of carbon is 4. So it is, you have to understand that it is the number of hydrogen atom. How many hydrogen atom is required by that element to form compound that forms their valency. Hydrogen valency is taken to be unit 1. 1 unit, 1, it is taken to be 1. So it is the number of hydrogen atom that will combine with or displace that one atom of that element or radical. So how many atoms of that element is required to combine with hydrogen that forms the valency of that element? So now in hydrogen chloride, HCl molecule, 1 atom of chlorine combines with 1 atom of hydrogen, hence valency of chlorine is 1. Now you can see in water it is H2O, 1 oxygen and 2 hydrogen. Oxygen requires 2 hydrogen to form compound. So valency of oxygen is 2. Hydrogen is 1 and oxygen is 2 because it requires 2 hydrogen. So in water H2O, 1 atom of oxygen combines with 2 atoms of hydrogen, hence valency of oxygen is 2. Now in ammonia, nitrogen requires 3 hydrogen. In ammonia NH3, the molecular formula of ammonia is NH3. Nitrogen requires 3 hydrogen, therefore valency of nitrogen is 3. Ammonia gas, in ammonia gas 1 atom of nitrogen combines with 3 atoms of hydrogen, hence valency of nitrogen is 3. In a methane, CH4, this is carbon, this is hydrogen, 4 hydrogen. Carbon requires 4 hydrogen. 1, 2, 3, 4, 4 hydrogen. Therefore, valency of carbon is 4. CH4 molecule, this is 1 molecule. 1 carbon atom combines with 4 atoms of hydrogen, hence valency of carbon is 4. So how that element, how many hydrogen it requires, it attracts to form a molecule, that is the valency of that element. So you have seen that hydrogen, the valency is 1. Hydrogen valency is 1. It requires 1 chlorine, therefore it valency of chlorine is 1. Now oxygen requires 2 hydrogen, therefore valency of oxygen is 2. Nitrogen requires 3 hydrogen, therefore the valency of nitrogen is 3. Carbon requires 4 hydrogen, therefore the valency of carbon is 4. Now some elements, they show more than one valency. That is known as variable valency. Let us see which metals have variable valency. Iron and copper, they are the metals which have variable valency. That is 2 and 3. Iron has got valency 2 and 3. Copper has got 1 and 2. So when it has got 2 valency, it is known as ferrous iron 2. And when it has 3, it is ferric iron 3. In copper, when it has got valency 1, it is known as cuprous copper 1. When it has got valency 2, cupric copper 2. So you just see that the suffix varies. When it is got lower valency, the suffix OUS is added, and when the valency is more, IC is added, us and ic. Same way for copper, when on the lower valency OUS is added, the higher valency IC is added. So it becomes cuprous when it has got lower valency and becomes cupric when it has got higher valency. So this is for the metals. Now even the non-metals, they have variable valency. Nitrogen, phosphorus, they have variable valency 3 and 5. And sulfur has got the valency 2, 4, 6. Now relationship between valency of elements and the periodic table. Now let us study the valency of first 20 elements of the periodic table. For that, you have to remember the elements, name of the elements. Now you have to develop some sort of rap so that you are able to remember all the elements. And if you remember the elements in the series, then you will know the valency very easily. So let's start. Now, hello, hi, listen, be, see, news, on, Friday night. Na मांग अल्लाह से पेप्सी सोडा कोला. ना मांग अल्लाह से S has to be there. ना मांग अल्लाह से पेप्सी सोडा कोला alcohol coffee, cafe. Now, first is hydrogen. Second is helium, helium. L is lithium. Beryllium. Boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Now these are the first 20 elements. Now we start writing the valencies. For hydrogen, it is 1. 1. Helium, it is 0. It is a gas which does not react. It's a noble gas. So, it does not want to react, no tendency to react. Its valency is 0. Lithium, it is 1. Beryllium, 2. Boron, 3. Carbon, 4. See, the valency is increasing. 1, 2, 3, 4. Now, after 4, again it will become 3, 2, 1. Now, after 1, it will become 0. Even neon, like helium, is a noble gas. It does not react. It has valency 0. So, it does not want to react. Helium, neon. Now, sodium valency is 1. Magnesium, it is 2. Aluminium, it is 3. Silicon, it is 4. Now, here, again, after 4, only it will be up till 4. Now, it will be 3, 2, 1, 0. Now, even argon is a noble gas. Helium, neon, argon. If they are noble gas, they don't want to react because their valency is 0. Since the valency is 0, they do not react. Now, after 0, potassium 1, calcium 2. So, you can see the rhythm. You can see the rhythm, how the valency is repeating. If the valency is same, the reactions, the chemical properties will be same. So, here you can see that hydrogen is 1, helium 0, lithium 1, beryllium 2, boron 3, carbon 4. So, here it from 0 to 4, it goes on increasing. But as it reaches 4, again it goes on decreasing in reverse. 3, 2, 1, 0. After 0, again it starts increasing. 1, 2, 3, 4. So, none of the elements are having more than 4 valency. After 4, 3, 2, 1, 0. And then 1, 2. So, these are the valencies of the first 20 elements of the periodic table. If you make a wrap of it and remember all the elements in series in lines first to 20, you will automatically learn the valency. And once you learn the valency, making the chemical reaction becomes easy. Now, after this, we will be studying the actual periodic table, why the valency is in such a manner that it repeats. Now, the periodic table is given by the International Union of Pure Applied Chemistry. It has got 118 elements. The elements are arranged in columns and rows. Now, as you in higher classes, you'll be studying the full periodic table. Now, you are only studying the part of the periodic table. See how the elements are arranged. They are arranged in vertical column and horizontal rows. Now, vertical column, it is up till 8 columns are present. 8 columns are present. Periods, they are up till 7, but you have to study only the small part up till 4. What you have to understand is that the elements, the properties, they are same in the same group. This is the group. When you say hydrogen, it is first group and first period. This is period 1, 2, 3, 4. This is the group 1, 2, 3, 4, 5, 6, 7 and 8. 1 is taken as 0. So here you can say for hydrogen, first period, first group. First group, first period, hydrogen. Lithium, it is there in the first group, but the period is second. Sodium is in first group, but period is third. Potassium is in first group, but period is 4. So this is the vertical column group, and this is horizontal rows, that is periods. Now beryllium, magnesium, calcium, it is in second column, second group, and period beryllium in second, magnesium third, calcium 4. Boron, third column, that is third group. Boron and aluminium in third group. Carbon, silicon fourth. Nitrogen, phosphorus fifth. Oxygen, sulfur sixth. Fluorine, chlorine seventh. A. Now this last 8 is taken as 0. They do not react. They are noble gas. Helium, neon, argon. Argon is the correct pronunciation. Now, what is the beauty of this periodic table? As in music, every 8th sound, sur, is same. Like sarigamapadani sa, sa, is every 8th sur is same. Same way, in periodic table, every 8th element has the same properties. Like here, this is 8th, hydrogen, lithium, sodium, potassium, their properties same. This is same, 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 this is same. So every 8th element repeats its property. Now, valency, you will see that it is for hydrogen, lithium, sodium, potassium, it is the group up till 4th. First group valency is 1, second group valency is 2, third group valency is 3, fourth it is 4. But after that it starts decreasing. After 4th, now it becomes 3, 2, 1, 0. So up till 4 it is increasing. You had seen in the previous table also how it goes on. 1, 2, 0, 1, 2, 3, 4, then 3, 2, 1, 0. Same way here it is same thing. This is the periodic table. This is how it is arranged in group and periods, and this is how the valency is according to the groups. According to the first, second, third, fourth group, the valency is 1, 2, 3, 4. But as 5th, it goes on decreasing. After 4, it is 3, 2, 1, 0. So this is the properties according to the valency. As you study higher, you will see why it is. So according to the group, the properties are same. Valencies are same. So here the elements are arranged accordingly in the vertical columns, that is group, and the period, that is the horizontal rows. This is according to, there are 118 elements, and it is according to the International Union of Pure Applied Chemistry. So this is how the elements are arranged in the periodic table. Now the molecular formula of a compound. It's a symbolic representation of a molecule. It shows the number of atoms, the types of atoms, and how many atoms are present in that molecule. That is the molecular formula. So a molecular formula of a compound is the symbolic representation of one molecule. It shows the number of atoms of each element present in it. These atoms combine in whole number. to form the molecule. Example, sulfur dioxide. Sulfur, one atom combines with two atoms of oxygen to form sulfur dioxide. So what you have to know is the symbol of that element. Formula, you cannot write full sulfur dioxide. That is not formula. When you write in symbol, then it shows the formula. So you should know the symbol and you should know the valencies. When you know the valencies, you will be able to make the molecular formula. Now writing the chemical formula of a compound. How do we write the chemical formula, molecular formula? Now left hand side you write whatever the elements. Calcium, here it is calcium. Right hand side it is chloride. Now write the symbol of calcium, Ca, chloride, Cl. So first step in writing the molecular formula, you have to write the symbol of the elements. You have written that correctly. Next step, write the valencies of the symbol. Now valency of calcium is 2, chlorine is 1. Write the valency correctly. Second step. Third step, interchange the valency. Valency of calcium is 2, it comes to the chlorine. Valency of chlorine is 1, it goes to the calcium. Now write the interchange number at the base. Whatever the number which you have changed, write at the base. So calcium you get 1, chlorine you get 2. Now the formula of the compound has been formed, CaCl2. Now how do we write the chemical formula for magnesium oxide? You should know the symbol of magnesium and oxygen. Once you know this symbol, you should know what is the valency. Valency of magnesium is 2 and oxygen is 2. Both have valency 2. When the valency of both is same, it gets cancelled. So how would you write the chemical formula? MgO. And remember, when you write Mg, this G is going to be small and O is going to be capital because it's a new element here. Here M will be capital. This is the scientific method of writing. So you should write the symbol and the valencies get cancelled. So it is going to be 1, 1, opposite 1, 1. The molecular formula, the chemical formula is MgO. Now same way, calcium, it is Ca. Nitride, it is N. You write in capital. So what is the valency of calcium? 2. And what is the valency of nitride? 3. Now this will go opposite. So what would be the molecular formula? CAN. This 3 will come here and this 2 will come here. So calcium nitride Ca3N2 will be formed. Now zinc hydroxide. Hydroxide is a radical. It's a radical. The valency of hydroxide is 1, zinc is 2. So it will come opposite. So it will form zinc hydroxide. Now this hydroxide will have the valency 2. This 2 will come here. So the compound form is ZnOH twice. Here there were no radicals, just elements. Now these are the radicals. Zinc is an element, OH is a radical, and radical has got valency 1. Zinc, the element, the metal, has got the valency 2. So now it is behaving as 1. This radical, oxygen, hydrogen, is behaving 1 with valency 1. So now opposite will come, zinc will remain, this one will come to the zinc, so zinc will be written as it is. This 2 will come to the hydroxide, so this 2 will be written here. So it is ZnOH twice. Now same way, this ammonium is a radical. ammonium is a radical and carbonate is also a radical. Now this ammonium has got valency 1 and carbonate has got valency 2. So now this will go opposite. Ammonium carbonate, the compound, how it is going to be formed. Ammonium you write as it is, this valency 2 write here as it is. 2 comes here. So here this radical you have written and the valency, after putting bracket you put the valency. Now this carbonate has got the valency of ammonium, which is 1. So it can, this compound ammonium carbonate can be written in this manner. Now the significance of molecular formula. It represents the molecule of a compound, the ratio in which the atoms are present in one molecule. And the molecular mass is the algebraic sum of the masses of all the atoms present in the given molecule. Now see, look at this H2SO4, that is sulfuric acid. How many atoms of hydrogen are present? 2. 1 sulfur and 4 oxygen. And here you can write 2:1:4, that is the ratio in which they are present. And to find the molecular mass, means mass of H2SO4, you can add the mass of hydrogen twice, mass of sulfur, and 4 times mass of oxygen, you get the mass of sulfuric acid. And whenever you write the number of molecules, if this is, when you write nothing, it is 1 molecule of H2SO4. If you want 2, you can write 2, it becomes 2 molecule of H2SO4. Same way 3, 4, you can write the number of molecules by writing the number before. So this is the representation of the molecule, that is the molecular formula, and helps to find out the number of atoms and the types of atom, and it also leads you to the knowing the weight, the actual weight of the molecule by knowing the weight of each atoms present in it.